Hi, this is Mr. Boughton, and we're going to look at some practice with reflections. This is not exactly the very first video or an introductory video because we've talked about reflections already before. We've seen how we can reflect over the x-axis like this. This is the x-axis when we're speaking of a coordinate plane, and we can also reflect across the y-axis, which is the vertical axis like this. And there's lots of real-world reflection examples that we can talk about, and we have talked about those already. And I kind of want to get into the practice of what happens on a coordinate plane when we reflect across the x or the y-axis, so that we can look at the points and see, numerically what happens to the numbers, the coordinates, when we reflect across these axes. So here we see a point. What is the coordinates of the point that you see right here? I want you to find the coordinates. If you need to, just kind of pause this video real quickly, in your mind, kind of write them down or think about them, and then unpause to take a look at the answers. So these coordinates, you should get 5, 3 for these coordinates. Always know how to write coordinates and find those coordinates. 5 is the x value. Of course, they're in alphabetical order, and 3 is the y value. That's because starting at the origin, starting here, we first walk along the x-axis. That's this axis right here. I can label that x. And this is the y-axis right here. So we walk along the x-axis to the positive 5. So 1, 2, 3, 4, 5. Notice I'm right on the lines. I'm not out here in the spaces. I'm not counting the boxes. I'm counting these lines right here. So this is where 5 is, and then we would go to positive 3 on the y-axis. So that means we're going to move in the upward direction. So that's 1 right here at this line, 2, and 3. Right here is where we put the point. Don't put your point out here. We're not putting a point in the space, or we're not counting spaces, so just make sure it's right on the line. So this point is 5, 3. If we reflect this point across the x-axis, where would we end up? Think of this point, I always think of it kind of as a tennis ball or something, and it is going over the x-axis, kind of like the x-axis is like a tennis net or a line that it's jumping over something. So it's moving down this direction. You can see the point's already there. So this point being reflected over the x-axis means it's moving downward across the x-axis. And it's moving the same distance away from the x-axis as it is in the positive direction. Now it's going in the negative direction, so the point is right here. So if we label this point point A, then the reflective point is called A prime. And we put a little mark right here. We call that A prime is the reflected point right there. So these coordinates for A prime, what coordinates would you get for this? You should go to, let me see, we still are walking to 1, 2, 3, 4, 5, still at 5, right? The x value did not change at all. In fact, the entire way across here, you can see that the x value is the same for all of these points that are along this line right here. But the y value is different, right? So we're moving in the downward direction, so it's -1, -2, -3. So the y value is the opposite value that we saw before. So the x value is the same, the y value is opposite. So what would we get if we took A, let's come back up here, and then reflect it across the y-axis? We're moving across this way. We're crossing over the y-axis. So where would we end up if we started here and then moved across the y-axis? Let me change my colors and go blue here. So here, if I just think this is 5 in the positive direction on the y, then I'm going to move 5 spaces in the negative direction and end up here. And this also is called A prime. Doesn't matter if you go over the y-axis or the x-axis, the reflective point is called A prime. So this point, let's take a look at its coordinates here. Go ahead and pause the video, find the coordinates of A prime over here. Okay, so starting at the origin, I notice in this case we are taking a walk along the x-axis. to the negative direction, so this is -5. And on the y-axis, we are still moving in the positive direction, still moving up in the same, that's the same way we did originally over here at our original A. So here's a summary. We first reflected across the x-axis. Look at these numbers. Do you see a kind of a pattern in here? Some things are the same and some things are the opposite, just like in an actual reflection. So when we reflect across the x stays the same. So if you that's kind of easy to remember. Reflect across the x-axis, the x will stay the same. And then the y is the opposite. If we reflect across the y-axis, let's use a different color here. Reflect across the y-axis going from here to here, then the y will stay the same right there. See, the y stays the same, and the x is what becomes the opposite. So whichever axis you reflect across, that coordinate will remain the same. That will help you if you're not looking at a coordinate plane. Now, sometimes we'll have problems where we look at the coordinate plane and then we can reflect and find our answers. And sometimes we're just going to have problems where we see a point and that's it. We're going to take a look at some practice here where you can just jot down the answers on a piece of paper, and I'm just going to give you a point, tell you what axis to reflect over, and you write the point that it would end up at. So get your paper ready, and you can just pause, then we'll go over answers at the same time. So pause and unpause as I go through each of these. So starting with this problem right here, so point 46, if you started here and reflected over the axis, hit pause real quickly, jot down your answer. You might already have it down. And then I'll go ahead and write the answer here as well. There you have it. You'll notice that the x is the same and the y is what is the opposite. Here's our next one. Here's our point. Reflect over the x. Go. And we're reflecting over the x. Okay, and we're reflecting over the x once again, so the x is the same, the y is the opposite. Next. Go. Okay, once again, reflecting. All right, once again, we're reflecting over the x-axis. It remains the same, and the y is the opposite. All right, let's move it up here and do another. All right, go. Here we're reflecting over the y-axis. So the y-axis is the same and the x-axis is the opposite, or the x-coordinate is the same. The x-coordinate is the opposite, the y-coordinate is the same. All right, go ahead and do the next one. All right, once again, the y-axis, that means the y is going to stay the same. And the x is the opposite. So here we go. Oh, that's a good 12 right there. All right, I think we got another one down here. All right, go ahead and do that one. So once again, the y-axis is the same. That would be 8. And, what's the opposite of 0? There is no opposite of 0, so it's just 0. So it will be the same exact coordinate right there. I think that's all I got right there. Okay, so that is some very quick practice without looking at a coordinate grid or anything, just giving you a point and an axis to reflect over. All right, that's it. Thank you very much, guys.